Mobile, I am not getting any update. Please let me know if you can hear me or not. Hello Sanjana, can you hear me? Please let me know if you can hear me or not. Okay, sure. Thank you for confirming, Vani. And yes, good evening, Sanjana, the classic Lithansa. Good evening. So there was supposed to be a surprise on yesterday, but due to some technical issues from our end, we are not able to complete that surprise. There was you will be notified with due time. Okay, it is paused for at least 1 week. Next week, sometime in the next week, we are planning to launch that surprise. We are planning to launch it. Right now, it is not going to come in this week. So we will inform you whenever the surprise is coming. Okay. For now, the surprise is not there, but the surprise is that today we are going to discuss moving charges and magnetism, and one more surprise that Chakravyuh classes are supposed to happen from Monday to Friday. Saturday, Sunday used to be off, but this week, Saturday, there will be a class of Chakravyuh of physics. Friday is definitely not my class. This Friday, Aishwarya ma'am will take the class, but to complete the syllabus quickly, I have requested to them to give me the studio on Saturday evening. Around 5:30 to 6, I will come live. I will obviously inform the time beforehand so that you don't miss out on my class. I will try to keep it at, as usual, 6 to 7:30, but in case there are some issues, then I can maybe prepone it by 5:30, but there will be class on Saturday for physics. Definitely mark it on your calendar. Don't miss out on the Saturday's class. So let's start with today's class first. So first question is easy question as usual. Always I try to start with easy question so that you get motivated. So first question is easy, and the rule for this class is whenever you are answering, answer with question number. For example, if you think question number 1 option A is correct, then you have to answer 1A or 1A or 1.A, whatever is convenient for you, you can answer like this. Okay, this is the rule for my class. Those who are joining for the first time, yes, Sanjana already started answering. Classic also answered. Classic Lithihasa. Okay, yes, Karthik. Vani, how much you will get, Sanjana? Bharat, yes, 1B. Yes. The correct answer is Orsted. I have discussed it in my Decode NCERT class as well, or also during my regular class. Orsted was the first person who discovered that concluded that moving charges or current produces magnetic field. So he has a very famous experiment of current passing through a magnetic needle. Now next question is not that simple. You have to read the question carefully and then answer. Okay. Second question is slightly tricky. When a magnetic compass needle is carried nearby to a straight wire carrying current, then the straight wire causes a noticeable deflection in the compass needle. So obviously option 1 seems to be correct. So if you have a wire carrying current and if you keep a compass needle, okay, compass needle near to a current carrying wire, it will give you some deflection. So normally if it is pointing north-south direction, that is a compass needle, but after you keep it near a current carrying wire, it will no longer point in the north-south direction usual. It will point some direction based on the direction of the current. Okay. Now this is the part 1. This is the statement 1, and this statement is correct obviously. Now second statement is slightly tricky. The alignment of the needle is tangential to an imaginary circle with straight wire as its center and has a plane perpendicular to the wire. Okay. So the alignment of the needle is tangential to an imaginary circle with straight wire. Okay, so that means the alignment is such that if you consider a circle, okay, plane perpendicular to the current carrying wire, then the alignment will be along the tangent. Is it correct or wrong? So I can say, Karthik, I am Varja Sayan, Yashash, yes, hi Yashash. So you changed your name, right? Okay. Hi Shaukat Ali, 2C, Vani, 2C. Yes, 2C is the answer. Both statements are correct. Actually, if you keep the needle, it will point the direction of magnetic field. Magnetic field represents the tangential direction to the circular. Magnetic field lines are circular for a current carrying coil, current carrying wire, and basically they will represent the direction of magnetic field which is tangential to the circle, right? Now statement 2 is also correct. Both statements are correct. Now question number 3. If a current I is flowing in a straight wire parallel to the positive x-axis, then the magnetic field is along the positive y-axis, then the wire experiences a force in negative x direction, negative y direction, negative z direction, positive z direction. Okay. So what they have said, so suppose we have say this is the coordinate system, okay, x, y, this is z, okay. So basically if you go from x to y, you get the z direction. This is the 3-dimensional representation, right? This is not two-dimensional representation that usually you do. So this is the x, into the paper is y, and z is upside, okay. So now they have said that current is in this direction, magnetic field is in this direction. What is the direction of force? Is it? So basically, as we know that it will be either positive z direction or negative z direction. Why? Because magnetic field lines are always perpendicular to both electric and magnetic field. So either it will be 3C or 3D. A, B is not possible. Anyone answered A and B? No one answered A and B. All are saying option D. So either it is positive z direction or negative z direction. Let's see. So if you put your fingers like this, okay. So as you can see, if you put, this is the direction of current, this is the direction of magnetic field, then definitely this will point towards the direction of force. Fleming's left hand rule, obviously it will be positive z direction. So positive z direction is the correct answer, right? Now next question. A strong magnetic field is applied on a stationary electron. Then the electron moves in the direction of electric field, remains stationary, moves perpendicular to the direction of field, moves opposite to the direction of the field. So here it is said that magnetic field is applied to the electron. Now what will happen to the electron? Shaukat Ali, Sanjana, most of you have answered it correctly. That is option D was for 3. Now Karthik is saying option 4D. Okay, Karthik is Rajasali, and I think Yashash, he is saying 4D, Classic saying 4B, Vani saying D, Lighting saying option 4C, Shaukat Ali saying 4D. Okay, so now very interesting case is, this is a magnetic field, okay, and from the Lorentz force we know that magnetic force is basically, the magnitude of magnetic force is Q VB sin theta, right? Now it is said that it is a static electron, that means the V is 0. So V 0 means does not matter what is the value of V, what is the value of charge, what is the value of theta, it will remain stationary. So be careful, if the question was electric field, then it will be opposite to the field, right? But here it is a magnetic field. So magnetic field move, if the charge particle is stationary, then it will not experience any force. That is the beauty of magnetic field. No, not Balaji, not 4A. Vani, yes, Vani has corrected now. Okay, Shaukat Ali was also saying 4D. No, not 4D. It is 4B. Okay, so the option is 4B. I hope most of you, whoever is answering it incorrectly, please have your mind clear. Magnetic field force is given by Q VV sin theta. even though the question appears to be very simple, but it is not simple. Here they have said that stationary electron means V equals to 0. So if V is equal to 0, the resultant force will be 0. Resultant force 0 means the electron will not move at all. Okay, clear? Any doubts? These are the questions that students make mistakes in the exam. Okay, this question will come in your PU exam, and you will by closing your eyes you will make option D correct. So that's why we have to practice, we have to understand the physics behind each and every question, what is the logic, why you have choose the correct answer. Okay, so remain stationary is the correct answer, right? Now question number 5. The radius of the circle described by a charged particle moving perpendicular to an uniform magnetic field depends on its mass only, its velocity only, both mass and velocity, neither mass nor velocity. So radius, so it has said that radius of a charged particle moving perpendicular to uniform magnetic field. Okay, suppose this is the magnetic field into the paper. Okay, magnetic field into the paper, it is moving like this, suppose. Now what is the radius of this? Not force, now we are talking about radius. Okay, this says that it depends on mass only, velocity only, both mass and velocity, neither mass nor velocity. Okay, yes. Just to refresh that, from the last question, FB was QVB. Now if it is sin theta, because they are perpendicular, so sin 90 degrees 1, so QVB is the force. Now because it is rotating in a circular path, this force has to be equal to the centripetal force, that is mv square by r. So now you can cancel one of the v's, so you can calculate the radius to be mv by qb, right? This is the formula for radius. If you don't remember the formula, you can approach like me, that I have done, that the force is actually equal to the centripetal force. From there you can calculate the radius. So it depends on mass, it depends on velocity, it depends on the charge, it depends on the magnetic field as well. So everything, these are the 4 quantities that depends. Now here they have only mentioned mass and velocity. Definitely both mass and velocity are dependent to the radius is dependent to both mass and velocity. Question number 6. The frequency of rotation of the charged particle in an uniform magnetic field is independent of velocity of the particle, charge of the particle, strength of the magnetic field. Okay, so velocity, charge, mass or strength of the magnetic field. Now we have to calculate the frequency of the rotation. Question number 6. What is the frequency? So we see that R is equal to, we have seen in your last case, R was mv by qb, right? Now you can write this v to be R into omega, okay, qb. So now you can cancel this R and you can write omega equals to qb by m. This R will cancel, so you can write this as qb by m. Now frequency is basically omega by 2 pi, right? So this is the formula for frequency. So you can write this as 2 pi qb by m. So definitely normal frequency is independent of velocity. Angular frequency is also independent of frequency. Omega is called angular frequency, or yes, qb by 2 pi m. So this is the formula. So obviously it is independent of the velocity of the particle. Good. Now next question, question number 7. which of the following statement is not true regarding Biot-Savart's law? So you have to recall what is Biot-Savart's law and you have to identify which one of them is not correct. So be careful, not true. They have said not true. That means 3 statements will be true, one of them will be not true. The magnetic field is proportional to the length of the current element. Okay, magnetic field is proportional to the current through the current element. The magnetic field is inversely proportional to the distance of the point. The magnetic field is proportional to the sine of the angle between the current direction and the line joining the current element and the point. So very interesting. Which one is correct? Yes, already someone answered it, Karthik and lightning. Okay, so 7C, because magnetic field dB is basically inversely proportional to the square of the distance, not inversely proportional to the distance only. So it is inversely proportional to the distance, which is incorrect. So you have to identify that. It might seem that all of them are correct. So which one is the not incorrect? So actually, because it is inversely proportional to the square of the distance, option C is the correct answer. Now question number 8. Pick up the pace. The value of permeability of free space is, easy question, permeability of free space. So 4 pi into 10 to the power minus 7 Henry per meter, 9 into 10 to the power 9 Newton meter square per Coulomb square, 8.54 into 10 to the power minus 12 F per meter, okay, farad per meter, or 3 into 10 to the power of 8 meter per second. Easy question, Balaji, no Balaji. Balaji, when you are answering, try to mention the question number, okay. So in case you may be answering question number 7, which correct answer option was 7C, but rest of the students are answering question number 8, so I may be confused. Hi Shankar, welcome. 8A, yes, 8A is the correct answer. We already know that. 4 pi by mu naught, we know the value of mu naught by 4 pi, right? Mu naught by 4 pi is 10 to the power of 7. So mu naught is 4 pi into 10 to the power of minus 7, and Henry per meter. Henry is the unit in case of magnetic field. Rest of the or electrical, these two are electrical, related to electricity, electric charges. This is Coulomb constant, this is epsilon naught, and this is speed of light. Okay, so these are the not the answer. So definitely this is the answer. Question number 9. A long straight wire carrying a current induced magnetic induction at any place that is proportional to the distance from the wire, independent of the distance, inversely proportional to the distance from the wire, inversely proportional to the square of the distance from the wire. Easy question. If you have answered question number 7, you can answer this question as well. Okay, let me see. Yes. So now here we are talking about long current carrying wire induced magnetic induction at some distance from the wire. Okay, long, very long straight wire. If you calculate it, it comes out to be the magnetic field is proportional to 1 by R. Okay, you can use Ampere's circuital law to find it, right? So it is inversely proportional to the distance from the wire. Okay, so I tried to distract you, but you didn't get distracted. You answered it correctly. Yes. Because it's a very long wire, you can apply Ampere's circuital law, okay, and you can calculate it. Okay, current induced is basically 2 pi RL, 2 pi R into B is basically mu naught I. From there you can calculate whatever the value of B. So basically you can see that B is mu naught by 2 pi I by R. This is the easiest way to remember from Ampere's circuital law. If you can apply Biot-Savart's law as well to calculate, but this is the easiest way. Okay. Next question, question number 10. An electron is projected with uniform velocity along the axis of a current carrying long solenoid. Which of the following is true? So, an electron is projected along the axis of a long current carrying solenoid. Okay, suppose this is the electron. The electron will be accelerated along the axis. The electron path will be circular about the axis. The electron will experience as a force at 45 degree to the axis and hence execute a helical path. The electron will continue to move with uniform velocity along the axis of the solenoid. Yes, yes, yes. So, hi Aishwarya, yes, 9C was the correct answer. Now answer this question. This is a very, very interesting question. So, an electron is projected along the axis, okay, of a solenoid. So, what will happen to this electron? So, either it will move in a circular path or it will move in a helical path. Either it will move in a circular path or it will move in a helical path like in this, or it will be accelerated. It will be simply accelerated along the axis, or it will continue to move with uniform velocity along the axis of the solenoid. Yes, yes, yes. Theta is 0. So, theta 0 means we know that QBV sin theta, that is the force. Okay, so this equation is very, very important as we can see. So, in this case, in case of a solenoid, the magnetic field lines inside the solenoid is parallel to the axis and it is constant also. It is parallel and it is constant. So, the magnetic field is not varying. So, magnetic field is constant inside the solenoid. So, if you pass an electron, it will either move in the parallel direction or it can move in the anti-parallel direction. Okay. So, theta is either 0 or theta is 180 degrees. Okay, because the direction is not particularly specified. So, it can either be 0 or can be 180 degrees. Now, in both cases 0 and 180 degree, sin theta becomes 0. So, definitely sin theta is equals to 0. So, sin theta 0 means this force becomes 0. So, electron will move with the same velocity with which it entered. So, definitely it is the correct answer is option D. Interesting, little bit thinking level question, but still not super difficult. Okay. So, as you can see, the questions are critical in nature, but you can solve it quickly if you have little understanding of the physics, right. So, if the beams of electrons and protons move parallel to each other in the same direction, then so beams of electrons and protons are moved parallel to each other in the same direction. So, electron is moving in this direction, protons are also moving in this direction, same direction. Okay, then they attract each other, they repel each other. Rho negation, neither attracts nor repel. Aishwarya is saying option A. This is an interesting question. Shaukat Ali is saying 11B. So, now you have to remember that there is a question, two current carrying wires. They are carrying, this is the simplest explanation that I can give you. So, two current carrying wire carrying the current in the same direction, what happens to them? They attract or they repel? So, basically if the current is being carried in the same direction, they attract each other. We have seen that, we have done the derivation, we have learned that when they are carrying current in the same direction, they attract each other, and if they are carrying current in the opposite direction, they tend to repel each other. Okay. Now, here you can consider that the motion of the electron is basically an current in the opposite direction, right. So, current is in this direction and the motion of the proton is like a current in this direction. So, you can consider these to be current carrying conductors carrying current in the opposite direction. So, opposite currents repel each other. So definitely they will repel each other. You can find the magnetic field due to this, and then you can apply on it, and you can find the direction of force on it. But this is the easiest explanation that I can give you, and it will be also helpful for you to remember in exam future that okay, what is the meaning of proton moving in this direction. Proton is like a current, right, in the direction of current, whereas electron moving is the current but in the opposite direction, right. So that's how you can clear any doubts that you might have. So they will repel each other. Okay, so this is the small tricks that you have to remember. Just don't answer thinking that okay, positive charge, negative charge, they will attract each other. It is not like that. Because they are moving, the situation changes. Okay, there is a magnetic field involved. So as soon as there is a magnetic field involved, there will be a different scenario. Okay, next question. Question number 12. A rectangular coil carrying current is placed in a non-uniform magnetic field. So rectangular coil carrying current, some current it is carrying. Okay. Placed in a non-uniform magnetic field. The coil, on the coil, total force is non-zero, force is 0, torque is 0, none of this. So let's see what is the answer. So when there is a non-uniform field, you have to remember that neither force is 0 nor the torque is 0. Torque will be definitely be there. We know that if we place a rectangular current carrying coil in a magnetic field, uniform magnetic field, it experiences a force, it experiences a torque. Because of that torque, it rotates, and based on that torque, if we can measure that torque, we have devices. For example, we have devices like galvanometer, we have devices like ammeter and voltmeter. They all work on the principle of this torque experienced by the coil. So here also the same thing will happen. Torque will always be there, but because the magnetic field is non-uniform, force is also be there, and force is also not 0. So it will exert a force on the coil as well. So question number, yes. In the uniform field only torque, in non-uniform field force and torque. It is applicable for electric field as well. If you remember, there was a question, a dipole is placed in a non-uniform electric field, it will experience only torque, only force, both torque and force. So it will experience both torque and force, right. In case of non-uniform magnetic field, a current carrying loop will experience force as well as torque, both will be there. Okay. In uniform field, net force will be 0, but in non-uniform field, one arm will experience force more than the other arm. Okay, so there will be net force will not be 0. Okay, if net force is 0, that means both arms are experiencing same force. Okay, so that will not be there. Now, question number 13. A conducting circular loop of radius r, okay, carries a constant current I. Okay, it is placed in a uniform magnetic field B such that B is perpendicular to the plane of the loop. The magnetic force acting on this loop is. Okay, so you kept this on a magnetic field, say into the paper. What is the magnetic force acting on this loop? Shankar, Karthik, 13C. Can you explain briefly in one line why it will be 0? So because this is a symmetrical circuit, symmetrical object, okay, whatever force will act on this, okay, so suppose there is a force acting in this direction, the force will be opposite direction. So there will be force acting on it in both sides and they will cancel each other, and this is a circular object, so all the points will have some force, okay, and they will have a diametrical opposite point where the force will be acting in the opposite direction. So these forces will cancel each other. So if you take the all forces, it will be 0, okay. You can consider like theta is 0 as well, but theta is actually not 0 here. Current is in this direction, magnetic field is into the paper, so theta is not 0, but here all the forces, sum of all forces will be 0, okay. Now next question, in a moving coil galvanometer, the deflection phi on the scale by a pointer is attached to the spring is, okay. Tell me the value. Phi is equals to, I told you a way to remember this. C, yes, yes Shankar, answer is correct. 14C is the answer. NAB by K, I told you nab it, nab means catching it, so nab by K into I. This is the expression for phi linked to a galvanometer coil deflection, okay. Now resistance of an ideal ammeter. Now we are moving into ammeter and voltmeter zone. Now what is the ideal ammeter, resistance of an ideal ammeter? Shaukat Ali, yes, 14C is the correct answer. Yes, Karthik, correct answer is 14C. Now question number 15, ideal ammeter is easy question, so I will not waste too much time. As soon as I get one answer, I will yes Vani, 15 will be 0. 15 will be 0. Ideal ammeter is 0, ideal voltmeter is infinity. You have to remember that, because ammeter is connected in series, so ideal ammeter should have a 0 resistance. Yes Shaukat Ali, yes Karthik, yes Shankar, yes Bhuban. So all of you are correct. Correct answer is 0. Now let's move on to the next question. A charged particle moves in a gravity free space without change in its velocity. Which of the following is not possible? So now they have, if you have followed initial few questions where we are discussing about static charge is moving in the direction of magnetic field. So here they have reversed the case. So basically without change in its velocity means acceleration is 0. Acceleration is 0 means definitely the force is 0. The Lorentz force is 0. Now Lorentz force 0, now they have given both electric and magnetic field in the options. So you have to be careful. So electric force is 0 as well as the magnetic force is also 0. Okay, so now they have said that which of the following is not possible. So very careful while answering this question. So for example, I can give you E is equal to 0, B is equal to 0. If E is equal to 0, B is equal to 0 means no electric field, no magnetic field. So definitely electric force and magnetic force both will be 0. Definitely this is possible. Okay, so this is possible case. So now we have to check which of the following is definitely not possible. Interesting question. So here they have given E is not 0, B is 0. Is it possible? In this case, E equals to 0, B is not equals to 0, and E is not 0, B is also not 0. 16B, 16B, 16B. Aishwarya, 15C was correct answer. 16B. Now 16B is okay. Why 16D is not possible? Tell me in brief. Why do you think 16D is not possible? Is possible basically. Why it is possible? E is not equals to 0, B is not equals to, B can still be not equals to 0. Why? Yes, correct answer is 16B obviously, but why this is possible? That force can be still be 0 even though both electric field and magnetic field is not 0, still the force can be 0, net force can be 0. Why? What is the reason that 16D is incorrect? Yeah, moving, no, no, not actually because of moving, because of that electric field and the directions of the fields are not given, they are vector quantities. So we know that Lorentz force is given by vectorially Fe plus Fb, right? Fe is basically Q into E and Fb is Q V cross B, right? So if this force becomes 0, if both of them are not 0, then this can still be 0 because the electric field can be such a way that is actually matching in the same direction opposite to that of V cross B. So they can balance each other. Okay, so they can balance each other. That means electric field can still be in the direction of negative of V cross B. So and they can balance each other, that is possible. So definitely this is a possible case, not an impossible case. Whereas if electric field is not 0, then definitely it will experience a magnetic field because this will still be there, this force will still be there. Right, this force will still be there. Now whereas if magnetic field is not 0, then still they can be perpendicular. V cross B still be 0 because V cross B can still be perpendicular and can still be 0. So this is not the sure shot case, this is sure shot case where force is not possible to be 0. Okay. Next question, interesting question, some thought provoking question, so that's why I discussed it a little longer than it required. Anyway, question number 17, a positive charge is moving in combined gravitational and magnetic field. Okay, so now here we have gravitational and magnetic field both. Very careful, the charge moves without any change in velocity, again the same case. Okay, charge moves without changing any change in velocity. If the velocity of the charge is along the east, so velocity is moving, so we know that this is north, this is south. This is east, this is west, this is generally our directions, right? Then the direction of magnetic field is along. Okay, so charge is moving in this direction, okay, and gravity is acting downward. Some force, the force has to be such that this force balances the magnetic force, right? So gravity, this is mg, this is the V cross B. Okay, this is V. Okay, one small change in this is gravity is not acting southward, but it is actually acting downward. North is south, west is on the surface of the earth, right? So that is the trick. So gravity is acting downward and the force is basically, gravity is acting downward and the force is acting upward direction and the charge is moving in this direction. This is basically z axis. Okay, this is xy axis and this is the z axis which is there, upward and downward. So this is mg, this is V cross P. Okay, now which direction the force should be there. Aishwarya is saying velocity selector. It is not actually velocity selector. Velocity selector is generally used in cyclotron. Okay, here we are mainly talking about balance of force. Okay, in cyclotron there is a fixed radius. Based on the radius, which you choose which velocity can sustain inside the cyclotron. So that is a velocity selector. Here it is not velocity selector. It is a just balance of force vector. What I say, cross product of vector basically. So V is in this direction. Okay, the gravity is acting downward basically into the paper, and the force has to be out of the page to balance it, right? So we say this is north, this is south, this is east, this is west, suppose. Okay, if I say it is like that, okay, north, south, okay, then this will be east, this will be west, right? This is our directions, and if the particle is moving without deflecting, that means whatever gravitational force is acting downward, that gravitational force has to be balanced by an equal and opposite upward force. Now what upward force can be there? That is only magnetic force, right? So magnetic force has to balance the electric force, right? So now we have to calculate, so that what is the direction of V cross B, so that V cross B is upward direction. So if V is in the east direction, what will be the force? When positive charge is moving in combined gravitational magnetic field, it moves without any change. Yes, charge acting on this is balanced. Yes, yes, 17 B. Why you are saying 17 B? It is Q V cross B, right? So Q is positive, Q V cross B. So charge is positive, so force has to be upward direction. Force has to be upward direction. So V cross B means only from, we will start from V, then we will move towards B, so that we get the force in the upward direction. Downward is the gravitational force. So V cross B. So B has to be in the north direction. B has to be in the north direction. V cross B should give us the direction of force, that is upward direction. This is upward direction, right? And the cross product means V cross B. V cross B. Your right hand finger rule that you have to apply, that if you start from one vector and slowly curl your fingers towards the second vector, then whatever your thumb represents, that is the direction of the cross product, right? So in this case V, we are starting here, slowly we are curling towards the direction of the second vector, so that we are getting the direction of the rotational vector. This is a kind of rotational vector, right? So this is the direction. So V cross B has to be in the upward direction, so B has to be in the north direction. So correct answer is 17A, not 17B. So after seeing the question, most students left. Only 2 or 3 students are still here. Anyway, let me move on quickly. So these kind of questions, and these questions are taken from your question bank. So if you think these questions are too difficult to answer, they will be there in your PU board exam as well, this level of questions. So if you are prepared enough to answer such questions, you will be easy, and this question can be asked as a easier version of K-set question as well. So those who are preparing for K-set, right? Now question number 18. A charge Q, a mass M is moving uniform circular motion under the action of a magnetic field B. If the radius of the circle is capital R, then the magnetic moment associated with the charge is given by. Very, very interesting question. So the question says that you have a charge which is rotating in a circular motion, okay. The radius is given by R, the value of the charge is Q. So what is the value of the magnetic moment of the charge? Question bank released by PU board, okay. If you can go to PU board website and you can search second PU question bank, okay, you will be seeing a new question bank. Previously there was a question bank which is very old, 2016 or 2017. So now they have updated the question bank for 24-25. Okay, it was not there last year. So last year students struggled a lot. There was a lot of complaint of MCQs being hard as well. So very unfamiliar questions were coming. So PU board had decided, okay, let's remove the ambiguity. We will give you 3 sets of paper. We will give you a question bank to practice from. Okay, even though question bank is little lengthy, you don't need to practice all the questions, but at least the MCQs you have to practice. If you are following our Chakravyuh series, all the questions from the PU question bank is covered. All the questions from your sample paper is covered. All the questions from at least 3 to 4 years of not 3 years, 3 years, 24-22, 2 years of previous year questions are covered as well. Okay, so all the previous year questions where MCQs were coming, so that is covered. Sample paper is covered. PU board question paper is also covered. Okay, so if you follow our series, every questions will be covered, all the possible questions, and also some interesting questions which I have handpicked from the NCERT book. So that is also being discussed, some new questions. Okay, now this question, what is the magnetic moment? Karthik saying 18C. Magnetic field is given, the radius is given, the charge is given. Okay, magnetic moment will not depend on the mass. Okay, it is only QBR. Okay, this is the formula that you have to remember. Okay, Shaukat Ali, why it was not upwards? Okay, why it is not upwards? Because they have asked only the direction of magnetic field, not the resultant force. Okay, so magnetic field has to be in the north direction, so that the resultant of V cross B is in the upward direction. V cross B has to be in the upward direction, so that it can balance the downward gravity. Okay, gravity is acting downward. Okay, and it is moving in a straight path. So who is balancing the gravity? Gravity can only be balanced by another force, right? Gravity is always acting on the charge. So which other force can balance it? In this case, only magnetic field force is acting. So magnetic force direction has to be opposite to that of the gravitational force. So gravitational force is acting downward. So the magnetic force has to be upward. Now the direction of motion is given towards east. So only way it can be balanced in the upward direction is B is in the north direction, right? If B is in the south direction, then it will add up to the gravity. So the force will be acting downward direction. If it is in the B direction, if it is in the west direction, then they are anti-parallel. So force will be 0. So it will be slowly, instead of going straight, it will go like this, it will fall like this. It is not falling, it is continuously moving in the east direction. That means whatever is the gravitational force acting downward, the same force has to be balanced by the upward force, right? Otherwise it will be a projectile motion. We already know that, right? I hope that clears your doubt. Now this is the question. Formula is QBR for magnetic moment. Okay. Now question number 19, statement 1 and statement 2. Statement 1 says that a current carrying wire is placed parallel to the magnetic field. Current carrying wire placed parallel to the magnetic field. The force on it due to the magnetic field is 0. Statement, the net charge on current wire is 0. Okay, net charge on current wire is 0, and magnetic field, suppose this is current carrying wire. Suppose this is the magnetic field. So this represents the magnetic field, and this is a current carrying wire. Now this question says that the net charge on the current carrying wire, is 0. Okay, both statement 1 and statement 2 are true, and statement 2 is the correct explanation of the statement 1. Both statement 1 and statement 2 are true, but statement 2 is not a correct explanation of the statement 1. Statement 1 and statement 2 are the statement 2 is false, statement 1 and statement 2 both are false. 19b, yes, 19b. Why 19b? Because yes, net charge is 0, but that is nothing to do with the force being 0. Okay, force is 0 because the angle is 0. Okay, so angle is 0 means that's why it is 0. Okay, it has nothing to do with the net charge being 0. Okay, so both statements are correct. Okay, if it is a perpendicular direction, then there will be a force. Okay, we have seen that this magnetic field, and they are sorry, not theta is 0, theta is actually 90 degree in this case. So the both magnetic field will not interact with each other at all. Okay, though it is Bill. So magnetic field due to the current carrying wire is like this. Okay, and because the theta magnetic field and these two are 0, so there will be no force acting on it. Okay. Now next question, match the physical quantities of column 1 with column 2. Current sensitivity, intensity of magnetic field, magnetic dipole moment. Okay. Current sensitivity is easy, intensity of magnetic field and dipole moment are little tricky. 19b. Oh, 19b is okay, that is fine. Now answer this question. One C, 2A, 3B. Shaukat Ali, why 20A? So current sensitivity is easy, as I said, current sensitivity is division per ampere. Now what is the dipole moment and what is the magnetic field intensity? Magnetic field intensity is ampere per meter and magnetic dipole moment is ampere meter square. It is the current into area, magnetic dipole moment, right? Current into area, right? So dipole moment is current into area, and field intensity of magnetic field can be represented using ampere per meter. Okay, so the correct option is 20B. Okay, 20B, yes, 20B is the correct answer, not 20A. Okay. Now question number 21, an ammeter and a milliammeter are converted from identical galvanometers. Which one has a smaller resistance? Ammeter, milliammeter both have equal resistances. The resistance of an ammeter may be more than or equal to that of ammeter depending upon its range. Very interesting question. So let us understand. So we have a galvanometer. Okay, we have a galvanometer. Galvanometer has a particular arrangement. So what we are trying to do? We are trying to keep the current here Ig, and here we have a resistance. Okay. So current through the galvanometer will always be the same, no matter if it is a milliammeter or it's a normal ammeter. Okay. Now based on it, okay, you have to adjust this resistance so that if some ammeter, say ampere current is coming, ampere is generally higher than milliampere, right? So suppose 5 ampere is coming, whereas the galvanometer can withstand maximum say 1 milliampere. Okay, so 4.9 ampere current. So 4.9 ampere current will pass through this. Okay, 4.9 ampere will pass through this, right? Now, if same galvanometer I am using, okay, I am using for milliampere. Now 5 milliampere current is passing, okay, 5 milliampere current is passing. So through this again will be same 1 milliampere current will pass, and through this 4.9 milliampere current will pass, okay. Shaukat Ali is saying it's B. Which one has a, remember that which one has a smaller resistance? Smaller resistance means the value of R will be small. Small this R, that means total resistance will be much more smaller. Galvanometer has a fixed resistance. Okay. So milliammeter does not necessarily need to have a very small value, because you are using it for measuring only milliampere currents, right. So but when you are using it for measuring higher current, that is ampere currents, this value should be so low that most of the current, higher amount of current passes through this shunt resistance. Okay. So ammeter must have a smaller resistance compared to a milliammeter. So even though this is very obvious, it seems that milliammeter measuring less amount of current must have a lower resistance. Actually no, because you are converting it from the same galvanometer. Okay, both the galvanometer has the same amount of maximum current, same resistance. So basically that means the current through the galvanometer for highest range, when the current, the maximum range it can measure is same, right. So Ig is same in both cases. So but in case of ammeter, the current in the circuit itself is very high. So whatever happened to the extra current has to pass through this shunt. Okay. So the extra current has to pass through the shunt. Now higher the amount of current, lower should be the value of the shunt, always. Okay, higher the amount of current, lower should be the shunt, so that that shunt can accommodate the extra current through it. Okay, if the resistance is high, okay, for ammeter suppose, then this much current will not pass through this resistor. Instead it will try to pass through the galvanometer, and the galvanometer will burn. That is not the purpose that we are using, right. So we have to allow the extra current to pass through the shunt resistance. So definitely ammeter will have a lower resistance compared to a milliammeter, even though it is very strange to sound, but this is a correct answer. Now again a similar question, match the following: magnetic field, magnetic permeability and magnetic moment. Yes, yes. In voltmeter it will be opposite. Yes, in voltmeter we have to apply a say it is a voltmeter and say millivoltmeter. Millivoltmeter requires a very less amount of current, so definitely the series resistance that you apply has to be smaller, whereas in case of ammeter current, when you are drawing very less amount of current, again you have to apply a very high resistance. So it is opposite to in case of voltmeter, whereas in case of ammeter it will be definitely an ammeter will have a less resistance compared to a milliammeter. Yes. Shaukat Ali saying 22D. Let me match it once and see. So magnetic moment, I will start with whatever I know, whatever I can remember correctly. So magnetic moment is this one. Okay, magnetic permeability is this one, and magnetic field is this one. So 1C, 2A, 3B. Yes. So definitely option D is the correct answer. Okay. Lot of good questions in this set today. Another good question. A charged particle of charge q moving in an uniform magnetic field, the angle between the velocity v of the charged particle and magnetic field B is theta. The trajectory of the charged particle varies with angle theta. Match the following table by choosing the appropriate trajectory traced by the charged particle for different possible values of angle theta. So, angle theta equals to 0, theta 0 means straight line, obviously theta 0 means straight line. Okay. Now, when it will be circle, when it will be helix, that is the question. Okay. So, 1 is B. Now, 1 is B is given in two options. Okay. So, in one case it is given that second 45 degree is circle, and one case it is given 45 degree is helix. So, let us see which one is the correct. Shaukat is saying 23B. 23B. So, 45 degree is helix and 90 degree is circle. So, any angle between 90 degrees and 0 degree it will be an helix, and it is does not necessarily to be 45 degrees. Any angle between 0 degree and 90 degree it will be a helix. Okay, and if the angle is exactly at 90 degree it will be a circle. So, circle is 90 degrees, definitely we know that, 45 degree definitely will be helix. So, option is 1B, 3A, 2C, 3A. Okay, so option is B. Right. So, option is B. Next question. The Lorentz force is the force on a charged particle moving in a region containing only electric field, only magnetic field, both electric and magnetic field, only crossed electric and magnetic fields. So, another easy question. If you do not understand the meaning of crossed, crossed means electric field and magnetic field are perpendicular to each other. So, electric field is in this direction, magnetic field is in this direction, this is called a crossed magnetic field. Okay. So, this is the question, easy question. So, this is the for explanation for option D. Okay, Lorentz force is the force on a charged particle moving in the region containing 24C. 24C, both electric and magnetic field. It does not depend on the orientation of electric and magnetic field. It only depends if both electric and magnetic field are present. If individually any one of them is 0, still fine, Lorentz force will still be there, but both electric and magnetic field is there, it is acting, right. If electric field is 0, then we can still say electric field is 0, magnetic field is not 0, right. So, Lorentz force will still be there, right. Now, next question. Force on a charged particle moving in a magnetic field is maximum when the angle between the velocity and the charge and the magnetic field is. Okay, so, velocity of the charge V and magnetic field, what should be the angle so that force acting on it is maximum. So, easy question, another easy question. So, FB is equal to QVB sin, what is the value of sin theta? When will be the force maximum? 25, yes Vani, yes, correct Vani. Vani, whenever you are answering, answer with the question number. You answered C, but if it is the answer C for this question, if you say C for this question, it is wrong, right. So, it takes some time for me to read your answers, because suppose I am telecasting it right now, it reaches to you after 10 seconds, then you reply, then I get the answer. Okay, so, there is at least 15 seconds gap between my telecast and your answering, right. So, that is why I say always mention the question number, that helps me to identify. Even if you answer previous question, I can still check and I can still say okay, it is correct or incorrect, right. Thank you Shaukat Ali. Minimum is 0 degrees, maximum is 90 degrees. Yes, sin theta becomes maximum when theta is 90 degrees. So, angle is 90 degree. Okay, now next question. A charged particle is released from the rest at a region of uniform magnetic field and electric field parallel to each other. The particle will move in a helix, a straight line, a circle, a cycloid. Okay. So, charged particle is released from rest at a region of uniform magnetic field. Okay, electric field is parallel. So, electric field, suppose this is electric field. So, whenever the question looks difficult, no, the answer is not super difficult. You have to remember this little trick. If the question seems easy, okay, either it will be easy or it can be tricky. But if the question looks tricky, actually it is not super tricky. Okay, only the concept may be little difficult. Okay, if you know the concept, you can answer it. So there is a charge given here. It is released from the rest. Released from the rest means you are just releasing it. No gravity is there. So electric field is in this direction. Magnetic field is in this direction. What will happen to this charge? Charge will move in helical path means like this. It will move like this. Okay, straight line. It will move in a straight line. It will move in a circle. Circle, obviously we know circular path, right? Or it will be a cycloid. Cycloid is like it is a helix, but it is in a plane. Okay, it is not moving in a straight line. It is like cycloid is like this. Okay. Now tell me the answer. 26C, 26C, yes, straight line, yes, straight line. Even though the question is appearing to be difficult, question language is difficult, answer is not difficult. Why so? Because when you, as soon as you release the charge, assuming this is a positive charge, this charge will experience the electric force first. Okay, magnetic force will not act as long as it is static. So when you are releasing this charge, only force is experienced by this charge is the electric force. So electric force will act in this direction. So it will start accelerating in the direction of electric field. So it will move in the direction of electric field. So whatever the velocity vector it has, whatever is the velocity vector will also be in the same direction of the magnetic field. So electric field, the velocity and the magnetic field, they are parallel to each other. Parallel to each other means the angle is theta equals to 0. So theta 0 means force will also be 0. So so what we have seen that based on the question analysis from your model question paper, previous year question papers, Lorentz force is given a lot of weightage from this chapter, right? A lot of question is coming based on the concept from Lorentz force alone. Okay, there are a lot of questions are there, but Lorentz force, if you see, at least out of the 35 questions we are discussing, Lorentz force itself consists of at least 10 questions, that is 30% of the questions are coming from Lorentz force. So that is why Lorentz force is very, very important for MCQ. A galvanometer can be converted into voltmeter by connecting, easy question, high resistance in series, high resistance in parallel, low resistance in series, low resistance in parallel. So galvanometer, you are converting a galvanometer converted into voltmeter. Okay, so galvanometer to voltmeter. Shubham, yes, 26C was the correct answer. Now 27. Why surface of a neutron star produces 10 to the power 8 Tesla of magnetic field? See, neutron star is still a researched particle. This is a mainly they are degenerate neutron particles are there, and magnetic field is very, very strong. Degeneracy is something completely different. Okay, if you have some interest, later on maybe I will make some video on neutron star, black holes and white dwarfs. Okay, so their state of matter is different. Okay, mostly it is predicted that they are in Boson state. Okay, you know that Einstein Boson state. So so there is a different state of material. Then there is a spin involved of the neutron. Okay, and neutron, even though you think that neutrons are neutral particles, so they do not have any magnetic field. Actually they have a very strong magnetic field, and we can detect it from Earth, and if they are rotating we call it pulsar. So there are a lot of different theory on that. What I know is that there is a reason is there is a degeneracy. So protons are not single protons. Okay, they live a many life in that state. Okay, so that is why they have a magnetic field. The reason and the mathematics is very different from whatever you are studying right now, and that will hamper your study for your final board exam. After the board exam you can come and I can ask, I will definitely try to answer. Actually, Vani, there is the interesting thing is that neutron is a neutral particle, right? So neutral particles should not have any magnetic field of their own, right? So we have seen that when the charge is moving, okay, basic, that is our normal electromagnetic theory. But neutron stars do not obey that electromagnetic theory, they obey something called quantum mechanics, quantum physics, okay, and that is a whole level of a lot of different kind of mathematics is involved, okay. Basic reason I can tell you is that degeneracy. Degeneracy means suppose I am standing here, okay, and instead of seeing me, you are seeing another me standing just next to me. So I am number 1, and after some time I am coming over here, and both of them are existing simultaneously. That is called degeneracy. Degeneracy means living multiple lives at the same time. It's like a science fiction movie, okay. So and they do it like that, and that is why there is a reason behind their magnetic field, which is completely different, very weird mathematics is involved. I cannot, that's why I am saying I cannot discuss it in this class. Okay, so correct answer is 27A, high resistance in series. Yes, correct answer. Let's move on to the next question. I have discussed a lot out of track. Dimensions of a magnetic moment is easy question. We have discussed this in a match the following question. MIR produces 3 Tesla. Yes. MRI, you are saying MRI, not MIR. MRI, yes, MRI machines, they produce about 3 Tesla. Yes. Okay. Aspiria, don't worry. I told you, even before the preparatory exam, if you have seen my videos based on preparatory exams are very much unpredictable, okay, and all the different districts, they try to prove that they are the best, okay, they are producing the best students, and in that race, okay, many district forms difficult questions to prove that they are giving the highest order of difficult questions, and they sometimes forget that there is a student who is sitting there who may not be thinking that I am the best, okay. So there is a very slight competition is going on between the districts. That is the main reason that the question paper of the preparatory is very much unpredictable. But if you see last 5 to 10 years of previous board year exams, the paper is very moderate, okay, and I will make one video very soon, maybe tomorrow or day after tomorrow, where I will give you basic chapters that you have to study to score at least 60 marks out of 70, not out of 100, 60 marks out of 70 if you study those chapters properly with your heart, okay. If you study those chapters properly, and obviously Chakravyuh series is there for MCQ questions. Apart from MCQ questions, all the other questions can be predictable, okay. Fill in the blanks easily answerable, so that's why I am not discussing fill in the blanks in our series. Fill in the blanks can be answered. Only problem student faced is that MCQs today also I have seen many students falling from the common traps. Even though the question is easy, students are falling for the common traps, so you have to be prepared for MCQ. Other than that, all the questions, all the important questions we have already given. If you want to score 70 out of 70, you can follow my Brahmastra series. If you are still not following it, don't worry, board exam will be predictable and you can easily score 50 to 60% marks, 50 to 60 marks. And if you are not doing the numerical questions, 50 marks guaranteed. If you are doing the numerical questions, 70 marks you can easily expect, okay. So don't be disheartened with the efforts. You should always remember that I should put my best effort in the exam. Whatever is not in my hand, I cannot control. So whatever my preparation level is, whatever my study level is, that I should maintain. Don't get disheartened. It will be fixed in the board exam, okay, as long as you are putting your best effort. Anthony sir, I am interested in joining your course for second PUC board and KSET 2026. When does the registration start for any app to be downloaded for Diksha? The inquiry is for my daughter, sir. Anthony, so if you want to enroll for KSET crash course, The link for that crash course is the inquiry form is given in the will be given in the description. You can contact our inquiry form for Diksha crash course cassette. We have launched the crash course, but that will happen only after your second PUC board exam is over. And regarding the second PUC exam test series that is going on, currently there is a very good offer going on in our channel, 26% up to 26% off on our second PUC preparatory exam, second PUC test series. The link also given in the bio. You can check in the description section of this video, and any other video, any of the videos that in our channel, latest videos, they all have the link for the PU test series. You can purchase that, and it is very less nominal price currently going on. We will soon launch cassette preparatory test series. Please wait for that. Right now our focus in more for PU board exam, because PU board exam marks are absolutely essential to get a good score in PU final board exam, right? So question number 28, we have I think till 36 today, so let me quickly complete this. 28 option is B. I think I have seen some answers, not Shaukat Ali, not 20 C. Sorry, my mistake, 28C. Yes, 28C, my mistake, I misread the question. So L square A, so area into current, so area is L square and current is ampere, so definitely dimension of magnetic moment is L square A. So Shaukat Ali, thank you for correcting me. Yes, okay, Subham is 80C, 28C, Vani 28C. Let's move on to the next question. We have a lot of distracted from the main topic. The current flows along the length, and any more questions I will please wait. I will address all of your queries at the end of this session. Okay, let me complete the questions quickly. 29, a current I flows along the length of an infinitely long straight thin walled pipe. Then the magnetic field at all points inside the pipe is same but not zero. So we have a thin walled pipe. This is I think from one of the previous year question. Okay, we have a thin walled pipe, current I is passing through this pipe. Okay, this is a hollow pipe. Pipe means hollow, obviously, right? Inside is hollow. So the magnetic field at all points inside the pipe is same but not zero. At all points inside the pipe is zero. Is zero only at the axis of the pipe. So is zero only at the axis of the pipe, is different at different points inside the pipe. Okay. 29B, 29B, one word answer. Why? One word answer. The law that is governing this answer, I just need the name of that law. No, not law of magnetism, not law of magnetism. It is the Ampere circuital law. Ampere circuital law says that if you consider a Amperian loop inside, so Ampere circuital law says that B dot dl equals to mu naught I. So here I is the current enclosed. Now if you see what is the current enclosed inside the pipe, no current is going, all the current is passing through the pipe, right? So no current is actually passing inside the pipe. So no current inside the pipe means I is 0. So I 0 means definitely B will be 0. DL cannot be 0. DL is a real portion, so you can see that DL will not 0. Only thing that is 0 is the B. So B is 0. Okay. So B 0 means magnetic field at any point inside the pipe is 0. Okay. Next question. Another easy question, parallel currents and anti-parallel currents. So we already discussed this question once. So no, not Gauss law, Gagan's plant garden. Oh, nice name. Not Gauss law of magnetism, it is Ampere circuital law. Okay, Gauss law of magnetism is something different, that is about magnets, static magnets. Okay, if you consider static magnets, magnetic field due to static magnet is 0, but when you are considering a pipe carrying current, then it is an Ampere circuital law. Okay. So parallel currents, anti-parallel currents. 1E 30A. Yes, parallel currents attract and anti-parallel currents repel. So not option A, it will be attract and repel, that is option C. So be careful, okay, both currents cannot attract. If parallel currents attract, we know that parallel currents, they apply force on each other, okay, they apply force on each other like this, so they attract each other. So definitely if parallel currents attract, then anti-parallel currents will repel each other, okay. So this there is a line mentioned in your NCERT book after the derivation, so you can check that. Yes, sir, enquiries for my daughter who is completed my first PUC, currently provided information for second PUC board and KSET 2026. Okay, Anthony, don't worry, I will give you one heads up for this, but please let me complete the lecture. I still have 8 minutes. I have to complete 5-6 more questions. So once I complete the questions, after 8 minutes I will answer your query. Okay, please wait for 8 minutes. Okay, question number 31. A planar loop carrying a current I having n closely wound turns and an area A possesses a magnetic moment M, where M equals to Ni by A, M is equal to A by Ni, M is equal to Nia, M is equal to 1 by Nia. Again easy question. Easy question. Please mention the question number. Shubham, Vani, Aditya, yes, 31C. 31C, National Investigative Agency. So I used to remember it like this: National Investigative Agency, NIA, which investigate terrorism, right? So this is the NIA. So magnetic moment is basically current into area and the number of turns associated with it. So that's how you can remember it. So NIA. Okay, question number 32. A charged particle is moving perpendicular to the magnetic field. Charged particle moving perpendicular to the magnetic field. Suppose this is the magnetic field. Okay, charged particle moving. Okay, if its speed increases, then its radius increases, decreases, remains the same. It depends on the polarity of the charge. Okay, so they have charge is moving perpendicular. So what is the formula for radius? So radius we have already derived it once. I am not going to do it once more, but if you remember it, just try to find it. So radius is basically proportional to the velocity. Okay, radius is proportional to the velocity. So if radius increases, if velocity increases, what will happen to the radius? Option A. Shubham, please mention the question number. Okay, that helps me to identify. So 32A is the correct answer. So we know that if velocity increases, basically radius is mv by qb, right? This is the formula for radius, exact formula for radius. So radius is mv by qb. So if velocity increases, radius increases. It does not matter on the polarity of the charge, may be positive, may be negative, but it is radius is independent of the charge. Okay, the direction will change. If it is positive, it will maybe rotate in the circular clockwise direction. If it is negative, it will rotate in the anti-clockwise direction, but radius will always increase. Okay, next question, question number 33. An electron is traveling horizontally towards the east. A magnetic field is vertically downward direction. Exert a force on the electron along. Another interesting question. We have solved a similar question. Remember that we have solved one question where we are finding the direction of magnetic field. In this case, it is saying that the charge is now moving in the east direction. Okay, and there is a downward force. This is north south, by the way. This is a downward direction. Downward direction is in this direction, right? So north, south, east, west is in this plane. Downward, upward is in the vertical plane, right? So you have to understand that. So magnetic field is acting on this direction. Okay, downward direction. So this is suppose north, this is south, and this is west. this is upward, up, this is down. Okay. So, magnetic field is in the downward direction. Now, what will be the force acting on this? What is the direction? How to calculate? I gave you one problem. Aditya saying 33D, Gagan's 32A, 32A is already corrected. Now, you answer this. Shaukat Ali saying 32D. So, how to find the direction of the force? So, direction of the force, we remember that force is basically V cross B, if you remember, right. So, we will first put our fingers in the direction of V and then we will rotate in the direction so that we get the direction, right. I think north, south, east, west. So, if you see that if I put my fingers in the direction of electric field and I rotate it, so my fingers are pointing in the north direction. Okay. So, if this is east, okay, so this is this is east, okay, this is west, okay, north, south, right. Now, particle is moving towards the east, okay, and magnetic field is downward direction. So, my finger is pointing in the south direction. So, south is the correct answer. So, option D is the correct answer, 33D. 33D, north, I think. So, this is suppose east, this is east, then yes, this is east, this is west, that means north is my behind, south is in my front, right. Or in the other words, if I say this is east, this is west, north is my behind, south is in my front, then it is moving towards the east. Yes, it will be in the north direction, sorry, it will be in the north direction. Answer is C. Yes. Shaukat Ali, no, 33C is the answer. Gagan, mention the answer question number. Sir, flow of electron is opposite to the electric current. Is it mentioned electron? Yes. So, for positive charge, the force will be in the north direction, but since the charge is electron, it is negative charge. So, negative charge, after calculating for the positive charge, you have to apply a negative sign to it. So, it will be south direction. Yes, correct Gagan, you are correct. So, 33D will be the correct answer. It will not be north, it will be south, okay, because electron was moving in the east direction, okay. Magnetic field is in the downward direction. So, you put your finger like this. So, it will be into the page means it is the north direction, okay. If this is east, this will be north, okay. So, there is a way to remember it. How you remember it? How to remember that if I put my hand in the east direction, this is west direction, which one will be north and south? So, I remember it from remembering the location. When I was a kid, I know that okay, this is the side from where the sun rises. Sun rises means that will be the east direction. So, from there I know which side is north, which side is south, which side is east. So, you just try to imagine in your head whenever you are facing this trouble, okay. So, if you put your hand towards the sun where the sun is rising, that means that is the east side, and the opposite side is west side, okay. And now you try to imagine which side was north from your, if you put your finger, suppose this is east, this is west, then your north should be in your behind and south should be in your front. Now, for positive charge, east to down will be in the north direction, but negative charge is negative, that means it will be in the opposite direction. So, it is a south direction. So, this is not a easy question. Even though the question looks easy, this is not a easy question. This requires a lot of there is a chance of making mistake because this is an electron, right. So, there is a chance of making mistake. Now, the resistance of an ideal voltmeter, we have already discussed this question. Fleming's left hand rule says about force, and it says about the current, force and magnetic field. Okay. So, here it is giving you the electron. Yes, you can apply the Fleming's left hand rule, but in that case you have to take the direction of current, magnetic field, and maybe it will give you the answer. You can try and find it out and let me know. Okay. But Fleming's left hand rule talks about the current direction and magnetic field direction. Okay. And it has nothing to do with the moving charge, and it assumes that they are in perpendicular always. In case of electron moving in this case may not be sufficient. Yes, I think you can apply. So, magnetic field, current, magnetic field, current is in this direction. Yes, yes, you can apply Fleming's left hand rule as well in this case. Okay. So, magnetic field will be downward direction, current will be in this direction. So, yes, you can apply Fleming's left hand rule and find it. Yes, yes, yes. 34C easy question, infinity. I will not waste time in this case. So, galvanometer has to have a infinite resistance. Now, in a moving coil galvanometer, a current I produces a deflection theta, then I is proportional to tan theta, I is proportional to theta, I is proportional to theta square, I is proportional to cube root of theta. Yes. 35, question number 35, I have one more bonus question, that is also easy, not super difficult. So, answer these questions quickly. Mohammad Zaid, I will answer your query soon, please wait. In a moving coil galvanometer 35B, yes, it is directly proportional to theta. Okay. It does not matter tan theta or tan theta or sin theta, it varies with theta only. Okay. Moving coil galvanometer. Okay. So, if it is rotated by an angle, you can calculate the angle as well, it is directly proportional to theta. Now, the last question, after that I will answer all of your questions. A moving coil galvanometer can be converted into a voltmeter by connecting a low resistance in parallel with galvanometer, a low resistance in series with galvanometer, a high resistance in parallel with galvanometer, high resistance in series with the galvanometer. Okay. I think it is the same question, only the language is different. So, a moving coil galvanometer can be converted into voltmeter by a high resistance in series with the galvanometer. So, option D is the correct answer. So, I have answered it, easy question. Yes, 36D, Aman, 36D. Okay. Shaukat Ali, yes. Vani, yes, yes, easy question, only the language is slightly different. So, that is why maybe that is a bonus question. Now, I will answer all of your questions, whatever questions you might have, please answer. Mohammad Zaid, we are planning to launch, we will launch in, give us one more week time. Okay, everything is ready, we will launch it soon and we will finish it before your PU board exams are over. So, by the time you are preparing for your PU board exam, if you are currently a second PU student, or if you are a repeater, you can follow us directly our one shot videos. If you are preparing for your PU board, okay, don't worry, our PU board preparation series will also continue along with this. So, by the time your PU board exam is over, you will get some time, all the videos will be ready, whatever chapter you want, you can study at your own time, at your own pace. So, by the time of your PU board exam is over, that is around mid-March, our entire one shot series for all the subjects will be completed. So, don't worry, that is already planned, we have a deadline, we are working on a deadline. So, that will be done very soon, but the series launch might happen after 1 week. Okay. Now, if Anthony is still here, Anthony, just for your information, that class, let your daughter complete your PU1 exam. We will have a PU1 passing package series coming up very soon for all the subjects, physics, chemistry and physics, chemistry, maths, bio. So, that will be there for a bonus, and for your daughter's second PU preparation, don't worry, we will be here and we will be provide you all the guidance, all the assistance that is required. We have some surprise planning for upcoming year of 2026 KSET, but I cannot reveal it right now. But definitely, if you connect with our channel, if you stay connected to our channel, definitely you will come to know as soon as the 2025 KSET exam is over, and we will share the plans for KSET 2026 exam. Okay. For right now, ask your daughter to focus on your final exam, final PU board exam, which is very important. 11th is a preparatory exam. It is a stepping stone of your second PU journey, right? Even though the marks do not count towards your final result, but it makes you either more confident, or sometimes it can demoralize you if your first PU exam is not good. Okay, so try to prepare hard. Very soon your final board exam will happen. So till then, just focus on your first PU. Once it is over, by the time it is over, our full-fledged preparation for 2025 KSET is going on. So once KSET 2025 exam is over, we will announce our detailed plan for KSET 2026, right? Yes, Gagan, everyone is right. If you have any more doubt, any more questions, please throw at me. Otherwise, I will conclude this lecture right now. I am already 7 minutes over. Okay, students. So thank you for joining in today's lecture. I'll be back on Saturday with a class. So don't miss our class on Saturday. Saturday I will going to discuss magnetism and matter at 6 p.m. sharp. So don't miss out our lecture on Saturday. Till then, bye.